3.01 will about electrical charges, conductors, and insulators. Now, conductors are great at conducting electricity. They're going to allow the electrons to flow through them easily. They're going to be great at conducting electricity. Insulators are the opposite. They're not good at conducting electricity. They're going to insulate it, and electrons do not flow freely through there. So let's make some hypotheses on what we think would be a good conductor to make the light bulb light up. To make your hypothesis, if we place the spoon here, would we make a light bulb light up? Yes or no? The DVD, a key, quarter, pencil, and scissors. So go ahead and make your hypothesis about this spoon, and let's try that out. All right, we'll put the positive and negative on, and it works. So if you had said in your hypothesis that yes, you believe this will work, then great job. Let's try the next one, the DVD. No, it's not. Now, what is the spoon made of, and what's a DVD made of? That would make that different. Think about that. The spoon is metal. The DVD would be kind of like more like a plastic. Plastics are really poor at conducting, and they're an awesome insulator. Obviously, spoons or metal are great conductors. We have the key. Make your hypothesis. Will it light up or not? Nope, it didn't. Oh, look, here's the plastic. Here's the metal. So that works until you put it on the plastic. If we switch it around, still doesn't work. You must have both on the metal. Then we have the quarter. What are we thinking about the quarter? Oh, again, a metal, so it works. The pencil is good. Is wood a good conductor? Well, I put it on the wood part. How about the metal part? And then the rubber part did not work for the eraser. But what if I put on the lead and the metal? How both on the metal? Nope, not a strong enough metal for it to work. So the pencil and the DVD have not worked. Let's do scissors. The plastic part doesn't work, but the metal certainly does. So what we've found here is that plastic is a really great insulator or poor conductor. Metal is a really great conductor or a poor insulator. So what is an electric charge? We have to consider the events at the atomic level, which is right here. First, an atom. What really is an atom? And that is the building blocks of matter. All matter is composed of atoms. This is the basic structure of an atom shown here in this diagram. Now these big orange balls are neutrons, and these big blue ones are protons. These little green ones that are floating around out here are called the electrons. The orange neutrons have a neutral charge. That even sounds the same. Neutral, neutron. The blue ones are positive, positive proton. Remember that. PP, positive proton, neutral neutron. The green electron has a negative charge. So when we have a neutral atom, we're going to see the same number of positive protons, the blue, and negative electrons, the green. That's when we have a neutral atom. Electrons, when they flow from one atom to the next, that's when we have an electric charge. So this is how it works. So a neutral atom, we just talked about that, it has no charge. We start there. The number of positive protons and negative neutrons, or negative electrons, is equal. So this makes it completely zeroed out. They're equal. If an electron, which is remember negative, moves from one neutral atom to the next, so if we let's take this green one over here, and let's move it over to this one, now we have more protons than electrons, which means it has a positive charge. And we had another neutral, and we added a negative electron over, we're going to now have this atom be a negative ion. So when we have a charge, they are ions. So now this one would be a positive ion, and this one would have a negative ion because we took this one and moved it over, making more positive ion, and then more negative, making that a negative ion. It has a +1 charge and a -1 charge. Let's see what happens. Now you notice how it became the +1 and the -1. Let's find out which ones are great insulators and great conductors. So I want you to go ahead and push pause, and you're going to drag one of these words over to whichever one you think it will fit with. Go ahead and push pause, and when you come back, we will continue on with this lesson. All right, now you've got a good idea of which ones are insulators and which ones are conductors. And insulators, remember, are really great at not allowing electricity to flow through it, and that's why we put rubber and plastic on the outside of our wires. And we use copper and metals for our wires because they conduct electricity, but we want to make sure we're safe, so we put the rubber or plastics on the outside. So it's a really great conductor when it accepts or transfers electrons quickly, rapidly. We do have things called superconductors, and these are really crazy fast at transferring electrons. We also have resistance, and resistance is how well a material conducts an electrical charge and is measured in ohms. Now think of resisting. Resisting means trying or stopping or not doing. So a strong or high level resistor would be found in an insulator. It's going to slow down or stop the flow of electrons. A low-level resistor would be in a conductor. It's going to freely allow the electrons to flow. We talked about the insulators, how it inhibits or stops the transfer of electrons, so there's no electrical charge flowing through it. And then we have semiconductors, which have properties of both insulator and conductor. They have properties of both. They're naturally going to be an insulator, but through a process we call doping, the materials can be transformed into weak conductors. Doping is a chemical process, and it involves adding an impurity like arsenic to a pure element similar to silicon. And this change increases silicon's ability to conduct an electric charge. All right, now that you have all of this great knowledge, you can go to the apply page and complete this assignment.